So I'm recording this video. It's an introduction for lesson 2.5. So before doing lesson 2.5 and doing all the transformations for the functions, I just want to remind you guys how do we graph all the functions, the known functions that we need to use in this lesson. So I will start first with the quadratic function. Already we did it before, but I will also remind you about it. We know that quadratic function means I have x squared and I have it's a U shape, either upward or downward. And we know that it's upward when A is positive and it's downward when A is negative. You could have a quadratic function developed like this, or it's in the same in the slope intercept form. So in both in the vertex form, sorry, in the both equation cases, I will draw it. I will take the first one. When you have it in the developed form, so first step, I need to find the vertex. And you know the formula already. So the vertex is minus b over 2a, f of minus b over 2a. So here it's going to be minus 4 over 2, so it's minus 2. And then when I do f of minus 2, I will have minus 5. So this is my vertex. Step 2, I start to take some points. And the best way, guys, all the time to find x and y intercept, and we know that not all the time x-intercept exists. So x-intercept, it means y equal to 0, and you know that is a quadratic equation. When I want to solve it equal to 0, I can do it on the calculator. It gives me those 2 points. Sorry. Y-intercept is for x equal to 0, it gives me minus 1. And you can even take more points. And as an advice, if you want to take more points, take some points before the vertex and after the vertex. I took also minus 4 because I know that minus 4 is going to give me the same y for 0. And then I will plot the points or the point that I have. This is my vertex. And I know that for the same axe I have, this is an axe of symmetry. So I know that this one will cut the figure into similar symmetric figures. So if I have this point here, the distance is 2, I can take it here also. So to have to be more accurate. So this is my vertex. This is the, sorry, y-intercept. This is the extra point that I took, and those two are the x-intercept. And all what do we need to do is to join. I need to join. I couldn't do it well. Okay, I need to join the points. Guys, if I want to continue drawing, you can take more points, minus 5, minus 6, and then the figure should be symmetric with respect to this axe of symmetry. So this is for the first equation. Sorry, I don't know what's happening to my voice. For the second one, if I have this form, this is the vertex form, I know directly from the formula, we know that it's x minus h plus k, so the vertex is 2, 4. And as an advice, guys, take all the time points before the vertex and after the vertex. It means bigger than 2, I took 3, for example, and less than 2, for example, I took 1. And I took for the y-intercept x equal to 0 is 0, 8. And I was trying to find the x-intercept here. For y equal to 0, this one will give me delta negative, so it means there is no x-intercept. So I know that this function will be above the x prime or x. Why above, not below? Because I know that it's a U shape. It's not, it's upward because A is positive. And then also again, you plot the points that already you got. I have it already here. So I have, this is the y-intercept. I have those 2 points. I can join here like this. Now, to be able to draw the proper point here, which one? This is the axe of symmetry. I know that. So if here there is 2, for example, 2 boxes. So here there is 2 boxes because it's symmetric. So I can join like this and I can draw all the graph. Now let's move to another graph, the rational function, the radical. That it's very easy also. All the time, guys, when you want to draw the radical function, the rational one, find the domain of definition first to know from where you're going to start to draw. So we know that under the radical should be bigger or equal than 0. So x bigger or equal than 0. So I'm sure that my graph going to be in this part here. And then start to take more points bigger than 0, 0, 1, 2. And then when you replace, here it's radical 2. So when you replace by the points x0, 0, x1, 1, x2, radical 2, and then you draw it, you're going to have this shape. Let's do another one. Radical x minus 2. What is my domain of definition? X minus 2 bigger or equal than 0, x bigger or equal than 2. It means I will start from 2. Here, how do we find the vertex? It's exactly like the quadratic. X minus h plus k outside. So the vertex is 2, 0. And then take more points bigger than 2. If you take 3, radical 3 minus 2 and a radical 1, so it's 3, 1. If I take 6, 6 minus 2, it's radical 4, 2, and then you draw the radical. I have this one here. What is the vertex? As I said, the formula is x minus h plus k. It's like the quadratic, but here it's radical. So it's minus 2, 1. So I know that I should start from minus 2, 1. The domain of definition is what? X plus 2 bigger or equal than 0. So x bigger or equal than minus 2. So I'm sure that I'm going to have the graph bigger than or equal than minus 2. So I can see it here. And then you take extra points. For example, I took here an extra point. Minus 1 gives me 2. And then I will graph it. And sure, in the chapter 2.5, we'll see all the transformation. If there is a minus here, if there is a number, what does it mean? But just here, I'm drawing the basics information for drawing a function. Now, let's move to the absolute value. Also, it's the same steps like the other functions. I know that it's a V shape. I will find the vertex, same formula, x minus h plus k. So I know that the vertex is 2, 3. And then you take points bigger than 2, less than 2. Then you join. It's here a V shape, so it's a straight line. So you can, with the ruler, do it and do this absolute value. Let's move now to the last one, the rational one. It's a little bit more complicated. The rational function, guys, it's 1 over x. First, I need to find the domain. Denominator not equal to 0. It means x is not equal to 0. It means this one, x equal to 0, becomes a vertical asymptote. Because I cannot find a value of y for x equal to 0. So we call it a vertical asymptote. It's like a bump, guys. It's like this is the boundary. So I cannot step on x equal to 0, but I can approach to it. You can stand here, but I cannot put my leg on it. It's a bump. I can turn around, but I cannot step on it. So that's why we call it vertical asymptote. How do we find the horizontal asymptote? Guys, you look at the fraction and you look at the degrees. When the degree of the numerator is all the time less than the denominator, it means the horizontal asymptote is y equal to 0. Why? I will explain it why now, but you're gonna see it later in the other chapters. We're gonna find the limit when x tends to infinity. And when I replace x by infinity, it gives me number over infinity, it's 0. That's why the horizontal asymptote is 0. But for the moment, we gotta just look at the degrees, and if the degree of the numerator is less, it's y equal to 0. If they have the same degree, I take highest over highest, and I will find the horizontal asymptote. Also, we will see it, guys, in the chapter. Now, to be able to draw, guys, I have two parts. I have this part in before x equal to 0, and I have this and this. The function is all the time. Either I have a graph here like this, either I have a graph here like this. On this part, either I have a graph like this, either I have a graph. It's all the time like this. How I will know where? It's very simple. All what do we need to do? I take a point less than the vertical asymptote and to see where is the location. Is it up here? It means it's here. Is it down? It means the graph is down. So I will take x and y. I will take minus 1. If I replace x by minus 1, the point is also for x minus 1, y is minus 1. So it means for x minus 1, y is minus 1. So I'm here. So it means that this part is here. It's not above x prime x. So it's either here or here. It cannot be on the two parts at the same time. Now I'll take a point bigger than 0, 1. If I replace x by 1, y is 1. The point is here, 1, 1. It means the second part of my graph is in this location. And as I said, when I say asymptote, it means it will approach to it. Look, it's going to be in the end as it's parallel to it. It will going to go near to it, but it will not touch it. If you feel that you want to be more accurate, you can take more points. The last example for the rational is a little bit more complicated. It's 1 over x squared minus 4. In this case, I have two values that makes my denominator equal to 0. It means I have two vertical asymptotes, x equal to 2 and x equal to minus 2. And the horizontal asymptote, as I said, since I have degree of the numerator less than the denominator, so y equal to 0. Guys, when I have two vertical asymptotes, one horizontal, I have this part here, I have this part here, and here. In this part, either the function is like this or like this. In this part, either it's like this or that or like this. The complicated part in the middle between the two functions, because sometimes it could be a u shape like this or like this, or sometimes also it could be in the middle like a snake. So this one, it's gonna be linked to what I have. We will see how we're gonna draw it. So in the middle, I have four different cases it could be, and in the other part, it's either up or down. How are we gonna do all that? Let's see this example. Okay. First of all, you take a point less than the first vertical asymptote. Then you're going to see the location. If it's here, it means it's up. If it's down, it means it's down. So if I replace x by minus 3, it will be 1 over 5. It means 0.2. So the point is here. It means the first part of my function is here. Done. Now for this part, I take the point 3, also it gives me 0.2. It means also that my part, my function is here. Excellent. The hardest part is here in the middle. But to be able to draw this, we will be drawing this using x squared minus 4, and then we're going to deduce from this one the 1 over x squared minus 4. This is what we are doing in our chapter lesson 2.4. So if I look at x squared minus 4, I know that it has a vertex, the minimum is 0 minus 4. So 0 minus 4, it's a minimum. When I make 1 over f of x, the minimum becomes a maximum, and 0 is still 0, but the 1 minus 4 will be 1 over. So it will be minus 1 over 4. And then in this case, this point gonna be a maximum. So if this point is the maximum, it means the parabola, it's parabola in the middle. And if I want to, guys, draw it more accurate, you can take more points. Let's take a point here. Let's take for x1, x and y. X1, what is y, guys? X1, y gonna be 1 over minus 3, minus 1 over 3. So it's here somewhere. Also, I can be more accurate. If I take x minus 1, it's the same answer. It's symmetric. It's a parabola. So it's also, if I want to be more accurate, my function gonna be like this, and it's in between. It's a parabola. And as I said, miss, all this we're gonna practice it more and more in the class. We'll have more example, but this is the basics. So all the time you need to take a point before, after, in between. You can take many points to double check your work. And that's it. This is just an introduction for lesson 2.5. Hope you like the video. See you in the next video, guys.